All right, and luckily I haven't been pulled over since then. Okay, so let's look. We did 31 on last time. Let's look at 32 because it's very, very similar. Read 32, what's happening? We are mixing solutions together. So we're in our notes. We're actually on page 20 of our notes, which should be the last page in your packet. And we're on problem, well, it says I, but it's number 32. Who remembers our setup for these problems where we are mixing some things together? Who remembers our setup? Eli?
The amount times the percentage, and then the other amount.
So plus, because we're mixing them together, we're adding them together.
Plus the amount times the other percentage equals the total amount.
Yep, that's exactly right. So these are the two we're mixing together, that's the final result. So in all of these problems, because that's the setup I'm using, and you can do it other ways if you want, as long as you get the right answer. There are 6 pieces of information that are required, 3 amounts, 3 percentages. So let's see what I've got in this problem. One is 20% acid. One is 35% acid. And we're gonna mix them together to get 25 liters of 26% acid. Agreed? Now, almost always when you do these problems, 4 of the parentheses get filled in, and the other 2 are kind of the unknowns. So I want to know how much 20% acid needs to be mixed with how much 35% acid. Now, be careful, because the temptation is sometimes to make this X again. We talked about that last time. Why do we not make that X?
We don't know that they're
Because we don't know that they're the same. And whatever you call X, that's X. So if you put an X here, then these would be equal amounts. So that's not what's happening. Or we don't know that that's what's happening. So what am I going to call this one? I heard something. 25 minus X is exactly what we're going to call it. For those of you that are wondering, where did that come from? First of all, keep in mind, let's just say I had 8 liters of this stuff, and I know I was going to end up with 25 liters. How much of this would I have to have? If I had 8 of those, and I needed to end up with 25, how much of these would I have to have? 17. And how did you get 17? You took 25 minus 8. So whatever this is going to be 25 minus it, because they got to add up to 25. And then we just have an equation to solve. So we can solve it. Times 0.35 is 8.75. Okay, let's see. This is just a regular equation. There's nothing fancy happening here. Okay, I got 15. Anybody else get 15?
Yeah.
So let's answer the question. The question was, how much 20% acid, and how much 35% acid. So what is this 15 liters? X belongs to 20%. And then we would have 10 liters of the 35%. Does that make sense to you? To answer the question completely? All right with that? All right. We're going to skip a little bit here because we got to get going here. 37. We're going to do 37. This one looks a little complicated, but I think you can figure it out. Water is stored in a conical tank, so that means it's a cone. So here's the cone. The tank has a depth of 24 inches and a radius of 9 inches, and it is filled to the brim. Okay. If the faucet is open, there's a faucet down here. If the faucet is opened to allow the water to flow at a rate of 5 cubic inches per second, what will the depth of the water be after 2 minutes? This is a tough problem. Does anybody have any idea about where to even start? What might we do first, Nyla?
Figure out the volume of the cone.
Okay, do you happen to remember the formula for the volume of the cone?
Is it the radius times the height, and then the...
It's called the slant height?
The slant.
No, I'm impressed you remember slant height, but not for volume. That would be for area, like the lateral area of it. No, the volume of a cone is actually just like a cylinder, except it's got a 1/3. It's 1/3 pi r squared h. Does that look familiar? So we can actually find the volume of this cone. The volume of this cone is 1/3 pi. 9 was the radius, right? I'll just make that 81. And the height is 24. Everything's inches, right? Yeah. So let's just go ahead and type that in. Let's see what we get. So 1 divided by 3 times pi. Remember, you have a pi button. Use your pi button. It's right here where I'm pointing. That's my pi button. Times 81 times 24. Did you get 2035.75 204 cubic inches? I won't round that off. I'll just write it all down for a minute. Anybody else get that?
Yeah.
Okay. All right, that's a great way to start. So now I know how much water is in the tank to start. Okay. Any thought on what we might do next? Eli?
Would you divide it by -5?
I'm not going to divide. Okay, I see what you're saying. If I wanted to know how long it took to empty it, I might do that. But that's not what I want to know. I'm going to open up this faucet and I'm going to let the water flow out for 2 minutes. And then I'm going to shut the faucet. And at that time, maybe the water level will be down here now. Does that make sense to you? Okay. All right, what do you think, Jackson?
Did you multiply by 120, the -5?
Okay, and what would that tell me? So that's what, 600?
Uh,
What does that tell me?
like how much, or how many inches cubed you're losing?
Okay, so the 600 is going out, so I could actually take this number minus 600, and this is my original volume, and my new volume would be 1435.75204 cubic inches. All right, let's make sure everybody's catching up with you, Jackson. Jackson says this is running out at 5 cubic inches per second. We're gonna leave it open for 2 minutes. That would be 120 seconds. So during the time that the faucet is open, I'm losing 5 times 120, or 600 cubic inches of water have come out, which leaves me with this much. So now I want you to look. Now let's consider the blue cone for a minute. The volume of the blue cone is 1/3 pi r squared h. But the blue R is this. This is the blue R. Put the 24 up there. And this is the blue H. Would everyone agree with that? And I do not know what either one of those are. That's the problem. So remember the other day when I told you that you often had to find another equation to kind of substitute in to get rid of a letter? I want to know what the new height of the water is. I need to get rid of this R so that I can solve for H. Because I know this number is 1435.75204. I know that. I need to figure this out. So I want you to dig way back in your geometry brain. I want you to look at this proportion. 9/24 equals R/H. I want you to look at my picture, and I want you to think about that for a minute. Do you remember what similar figures are? Similar figures are figures with the same exact shape. Proportionally, they are identical to each other, but one's bigger than the other one. Those two cones are proportional. So the ratio of the black radius to the black height is going to be exactly the same as the ratio of the blue radius to the blue height. Does that make sense to you? So R equals 9H/24. I know that radius is yet. But if I multiply the H over here, R equals 9H/24. And now I'm going to take that right there, and I'm going to plug it in right here. And then I'm going to be able to solve for H. Because the question was, what will be the depth of the water? So what's my new H, Meg?
Oh, I was gonna ask if you could simplify the 9/24.
I'm going to do that, yep.
Okay.
Yep, absolutely, I'll make that what, 3/8?
Yeah.
Ain't gonna affect my answer a bit, but it's going to make my numbers a little bit handier. So 1435.75204 equals 1/3 pi times 3H/8 squared, that's R squared times height. 143575204 equals, all right, let's clean this up. What's that? Three H/8 squared would be 9H squared over 64. Guys, I know it's after lunch, are you with me here? Can I cancel that 3 into this 9? So 3h cubed pi over 64. Take a look at that, make sure you can digest that. Now we're solving for h. So what do you think I might do next? I'm gonna do the next part just totally on my calculator. I'm not gonna write any more down for a while anyway. This number is on my calculator. I got it right here. What am I gonna do if I'm trying to solve for h? Multiplies, I'll just do times 64. All right, so now that's gone. I brought it over here. Okay. Now, what do I do here? I'm gonna try to solve for h. So what do I need to do? Divide by 3. Done. Okay, so I divided by 3. What else do I need to do? Divide by pi. Done. So now I have h cubed equal to this crazy number. Now what? What do I do with get h?
Take the cube root.
Cube root. And when you cube root, I think we talked about this, but when you cube root, there are actually a couple different ways you can do it. You actually have in your math menu, if you go math, and look in that list, you see a cube root option. So you can actually do that. So if I click down to cube root, this is the number I want to cube root. And if I don't want to retype it or round it off, I can do second answer. And it'll put that right in there for me. And 21.36 is what I got as my height. The other way you can, and that would be inches. The other way that you can do it is if you remember that cube rooting is the same as raising to the 1/3 power. So if you want to, instead of messing with the cube root button, if you just want to go straight to raise it to the 1/3 power, you can do that too. I often do that. Okay, did anybody else get 21.36 inches? Did anyone else type it in?
Yeah.
Okay, thank you. Thank you. That's a tough problem, guys. That problem will distinguish the men from the boys and the women from the girls. All right, we got 2 more to do. 2 more, and then we'll be done with this. So we're gonna do number 38. Reggie invests his money. How much is invested at each rate if Reggie's total annual interest is $900? So here's, all right, Reggie's got how much money? $12,000. He's splitting it up into 2 accounts. Do we know how much money is in each account? No, isn't that what we're trying to figure out? So let's call this amount X. He puts X dollars in this account. Well, if he had $12,000 altogether, and he put X in this account, how much did he put in this account? 12,000 minus X. It's just like our mixture problems, right? The 2 together have to add up to 12,000. Now, how do we find interest? You remember from a long time ago, there's a little formula, I equals PRT? Charlie, don't you shake your head at me. I equals PRT is the formula for simple interest. Interest equals principal, and that's the money that you invest, times the rate, times the time. Now, we're gonna do this for 1 year. Yeah. Total annual interest is $900 for 1 year. So our time is gonna be 1. So we can kind of just ignore that, because it's just gonna be 1. All right, so let's take this account. What's the principal? X, that's what he invested. What's the interest rate for that account? Read the problem, what is it? 7%? I don't remember, I need you to help me. 7%. All right. This, he's investing this much money. What's the interest rate for that account? 0.085? 8.5%. And that interest plus this interest is gonna add up to the total interest, which is $900. This isn't a mixture problem, you guys, but isn't it set up the same way? Amount times percent plus amount times percent equals the total, which they told me was 900. I don't have to figure that out. All right, let's solve it. Here we go. I think my arithmetic was right. I used my calculator for most of it. 8,000 here and 4,000 here. Anybody else get that?
Where'd you get 1020 from on the second line?
Distributing. All right, one more. Try to stay with me. Try to stay awake. Number 39. Number 39. You've done these in chemistry. Not this exact kind of problem, but this type of problem you've done. We got a tire of a moving bicycle that has a radius of 16 inches. So the radius is 16 inches. The tire is rotating 2 rotations per second. So 2 rotations per second. Find the bicycle speed in miles per hour. I need more realism over here. All right, so the wheel is rolling at 2 revolutions per second. Somehow, I gotta mess around with that and get it to miles per hour. Just like in chemistry, when you start, and I'm totally making this up because I don't remember anything about chemistry, but when you start with moles per something and you have to get it down to liters per centimeters or something, right? What do? You start doing your different conversion factors, right? Now, seconds to hours is easy. I know that there are 60 seconds in 1 minute, and I know that there are 60 minutes in 1 hour. Now, does everybody know why I set it up 60 seconds over 1 minute? So these cancel, that's the whole point. I gotta get from seconds to hours, and I've done it, right? So now I've got my hours. Now I gotta get from revolutions to miles. So remember they told us the wheel had a 16-inch radius. Remember that? Think about it. Isn't a revolution of the wheel just the circumference? And isn't the circumference of a wheel, or of a circle, 2 pi r? So can I say that 32 pi inches is 1 revolution? Because a circumference, which is 2 times pi times the radius, a circumference is a revolution, would you, right? So now I got rid of that. But now I gotta get from inches to miles. So let's see, I know there are 1 foot, 12 inches, and again, I'm trying to make those cancel. I know 1 mile is 5,280 feet. Oh my gosh, are we where we need to be? The only unit left on the top is miles, and the only unit left on the bottom is hours. So let's type it in and get the answer to the question. You do whatever you want. I'll tell you how I'll type it in. I'm gonna type in this is all multiplied. The entire problem is multiplied. It will always be multiplied. I'm gonna multiply everything on the top. So 2 times 60 times 60 times 32 pi, using my pi button, equals. Did you get like 723,000? Okay, now, that number needs to be divided by all of this, right? So that I think the easiest way to do it is, well, these are all ones, so I don't need to worry about that. Divide by 12, just hit divided by 12, and then divided by 5,280. Because don't we want to divide by both of these numbers? So we'll divide by 12 and then divide by 5,280, and that will give me 11.42 miles per hour. That's how fast the wheel is spinning. The issue, the thing that holds us up on these problems is we have to remember that a revolution is a circumference. If you can remember that, then the rest of this is easy. Inches to feet and whatever, all that's easy. Remember that a revolution is a circumference. Okay? All right, that's enough of that. I know I skipped a couple. Do not fear. Your test is not going to be over anything we skipped. However, your test will have word problems on it. So next time we are together, we will begin going through some of these review materials that I gave you. My guess is, help me, do I see you tomorrow? All right, then I'll see you Monday. And I'll see you Tuesday. And then the next time I see you after that, whether it's Wednesday or Thursday, I don't know, will be our test. Okay? Got it? So the test is either going to be Wednesday or Thursday, depending on when I see you. I guess I can look that up. I have my plan book right here. I think I see you 3 days in a row. Wednesday. The test will be Wednesday. Right after lunch, when you're sleeping like you are today. Okay, Robbie, I'll need to see